Well, Mr. Thompson here with a science video lesson, and we're going to do some example problems, work through the solutions for a couple of physics problems involving acceleration. Okay, let's get right into it. We've got two problems today. Here's the first. Example 1, a skater increases her velocity from 2.0 meters per second to 3.0 meters per second in 3 seconds. What is her acceleration? Now, let's not get started on, whether or not skateboarders really, or whatever it is, roller skaters maybe, are measuring their velocity to 1 decimal point. Doesn't matter. In this case, that's what's going on. Okay? Now, we are going to use our formula for acceleration. A equals delta V over T. And delta V, of course, is the change in velocity. So the second velocity, take away the first velocity, V final minus V original. In our case, it's 3.0 is the ending velocity, and 2.0 is the starting velocity. So we're going to do 3 minus 2, which is, of course, 1. So the change in velocity is 1. So we're going to have acceleration equals 1 over the time, which was 3 seconds. And that's the answer. So you can write it out as, 0.3. We can round to 0.3. But that's the answer. We do need our units. And it was meters per second divided by seconds. So meters per second over seconds, which we write as meters per second squared. All right? One problem done. Next one. A car accelerates at a rate of 3.0 meters per second squared. If its original speed is 8 meters per second, how many seconds will it take to reach the final speed of 25 meters per second? Now, this one, it gives us the acceleration, and it asks how long will this take. We're still going to use the same formula, all right? So we still have our trusty acceleration is delta V over T, change in velocity over time. And once again, change in velocity is the final velocity minus the original. So we're going to have 3.0 equals. So we replace our A with our acceleration because we know what the acceleration is. So we just plug that in, and then we have 25 minus 8, the final velocity minus the original, divided by the time. But we don't know the time, so we're just going to leave it as an unknown T. We only have one unknown, so we know from algebra that when there's only one unknown, we can certainly find what it is. Now, we're going to do some algebra. Most of you who are good at algebra can probably do this really quickly. In one step, I'm going to do it in two, just in case. But what we're going to do, we want to get T by itself. We want to know what is T. So we're going to rearrange this equation so that T is out by itself and all the numbers are on the other side. First thing I'm going to do is multiply both sides by T. Okay, so multiply the other side as well. Of course, the two T's cancel out. So we get 3T equals 17. Now, the 17, hopefully everyone can see, came from the 25 take away 8. I just simplified that to 17. Now we divide both sides by 3. Those 3's cancel. 17 divided by 3 is not quite 6. It's 5 2/3. So we can round that to 5.7, and we need our units. Now, we had acceleration. Ultimately, what we ended up with was 17 divided by 3. The 17 is meters per second, and we're dividing by meters per second squared, which is a little, confusing. But ultimately, we know that our answer is time, and it's going to be in whatever, as long as our units of time are consistent between our velocity and our acceleration, then we're fine. So, it's good that this wasn't like 17 kilometers per hour in 3 seconds, right? It's meters per second and then meters per second squared. So our answer is going to come out to seconds. And if you do the maths, the units cancel properly, and the answer is, of course, 5.7 seconds. Easy. Catch you next time.